I'm gonna teach you exercise 2.5 differentiation question number 2 part 2. Tan cube theta secant square theta. And first step is always y. We will suppose. In question, if this term is in the form of supposition, for example, y is equal to this term or u is equal whatever, so we will never suppose in the second step. Here there is no supposition, so first of all we will suppose y is equal to tan cube theta secant square theta. Now here variable is theta, so we'll differentiate with respect to theta, dy by d theta. In the right side variable is theta. Now we can see that this is one term and this is second term, so this is first term and this is term. So we will use product rule because derivative of any two product variable is u derivative of v plus v derivative of u. Here apply this rule. Now we consider this term as u and this term as v. Now u is tan cube theta derivative of with respect to theta d theta, derivative of v is secant square theta plus v is secant square theta, derivative of u is tan cube theta. Now tan cube theta derivative of secant. Now here this is not a simple secant theta, so first of all we will apply power rule. Power derivative of any power variable is nx n minus 1. So here 2 secant theta, n is 2 secant theta and x is secant theta, and x 2 minus 1 becomes 1, and derivative of secant theta whenever there is power, first of all we will remove the power by applying power formula. After solving the power formula, we will take the derivative of the term. Now here the term is secant theta, so we will simplify it, and now the term is secant theta. For example, if we have derivative of secant 4 theta, now what we will do, we have first of all will apply power rule. According to power rule, n is 4 secant 4 minus 1 theta, and derivative of, now here apply the power rule. After applying the power rule, we will take the derivative of whatever term. Now here term is secant theta. Now similarly tan cube theta to secant theta, derivative of simple secant theta plus secant square derivative of tan cube. Here again we apply power rule, and according to power rule n x n minus 1 theta, and derivative of tan theta, simple tan theta. Now tan cube theta to secant theta derivative of secant theta is secant theta tan theta, secant theta tan theta plus secant square theta 3 tan 2 minus 1 becomes 2, 3 minus 1 becomes 2 theta, and derivative of tan theta is equal to secant square theta. Derivative of tan x is secant square x, and derivative of instead of x here variable is theta given, so derivative of tan theta is equal to secant square theta. Secant square theta. Now further we will simplify. Now we simplify to secant, this power is 1 and this is 1. 1 plus 1 becomes 2 secant square theta, and 3 tan theta. 3 here power is 1. 3 plus 1 4 plus 3 tan square theta, and secant theta 2 plus 2 becomes 4. Now what is common? Secant square theta and tan square theta. What is left? 2 tan square is left plus 3 secant square is left. So dy by theta is equal to secant square theta tan square theta into 2 tan square theta plus 3 secant square theta, which is required solution.